And the set-based matrices are basically recall and precision. Let's say again, this is the collection of the entire document set. Let's say for a given query queue, this is basically the circle in red, not actually circle, and the ellipse in red is containing all the retrieved document by some retrieval model M. So the M retrieval model is retrieving these documents, all these documents. And out of this, only this much is actually relevant. And this much of the relevant document which are present in the collection, but it is not being retrieved by the retrieval model. So again, if we consider this Venn diagram, this is the entire set of retrieved documents. So this portion, and this is the set of documents which are relevant. And of course, you can understand that the circle with both the intersecting portion of this Venn diagram is basically the documents which are retrieved by the retrieval model M, which is also relevant. So based on this set-based measure, like if we exclude or if we overlook the ranking for the time being, if we just check whether a retrieval model is retrieving a set of relevant documents or not, at which position we are not bothered about that, then we can measure using recall and precision. Now, okay, so before that, let's discuss another thing that is called a confusion matrix. This is called a confusion matrix. Here, in the row, in the first row, it is basically the irrelevant or non-relevant document. In the second row, it is basically the relevant documents. And this is basically indicating the retrieved documents and not retrieved documents. So a document, any document D, if we select any document D from belonging to the collection C, D will be what? D will be, number one, D will be either relevant. Relevance of D will be 1. That is, D will be relevant. 2, it will be basically non-relevant, right? And another thing is from the perspective of retrieval. So if I make it, so this is from the perspective of relevance. And if I look at them from the, if I look at a document from the perspective of whether it is retrieved or not, so again, it will be either retrieved by M or basically not retrieved. I'm just using this not operator here, exclamation mark, not retrieved by M. So this is from the point of view of retrieval, whether retrieved by the system or not. So this is actually making the confusion matrix. In this confusion matrix, here the individual columns are basically stating, so this is whether it is, the individual columns are stating whether it is retrieved and whether it is not retrieved, as I have written here, retrieved and not retrieved. So basically this one. And by the row, I'm specifying whether it is relevant or non-relevant. So relevant, this row, non-relevant, this row. So given a document, what are the possibility of it is relevant? So what are the possibility of relevance and retrieve? So it can be either relevant and retrieved, relevant plus not retrieved, non-relevant plus retrieved, non-relevance plus not retrieved. This means the document was relevant and it is retrieved. Retrieved means the retrieval system M is predicting the document to be relevant one. That's why it is retrieving it. So this is called true positive. Relevant and retrieve. Relevant and retrieve. True positive. Now let's consider the next one. Relevant but not retrieved. That means the document was actually relevant, but the retrieval model is predicting it to be non-relevant. So that means we are, considering a relevant document as non-relevant one. So this is called false negative. We are predicting it as negative, but which is false. The system is predicting the document to be negative, that is non-relevant, but it is actually relevant. So that's why it is false negative. Relevant but not retrieved. Next is non-relevant but retrieved. That means the document was actually non-relevant, but the retrieval system M is predicting it to be relevant. That's why it is retrieving. So that means it is true negative. It is actually negative. Extremely sorry. It is basically this one, false positive. Extremely sorry. False positive means I am, or the retrieval system is predicting it to be positive, but which is false. The retrieval system M is predicting it to be positive. That is predicting it to be relevant, but it is not actually relevant. That is, it is predicting a false positive value. So this irrelevant, non-relevant, but still retrieved. The fourth one is non-relevant. The document was actually non-relevant, and the document was actually not retrieved by the retrieval system as well. Like a document which is non-relevant, and the retrieval system is also predicting that it is non-relevant. It is called basically true negative. That is, it is actually negative, and the system is predicting it to be true. That is, it is predicting it to be non-relevant. So now if I compare the color, the true negative documents are basically in this gray. You can understand. This green documents are basically only the false negative documents. That is, all those documents which are relevant but which were not retrieved by the system. The brown documents are basically the documents which are retrieved by the system and which are relevant. And this basically, I think this is a magenta color. This, or you can say pink. This pink shaded portion, these are the documents which are actually relevant, retrieved by the system, but which are not actually relevant. That is, they were actually false positive. Now note that as we are discussing, a retrieval system will definitely retrieve, definitely it will be retrieving some non-relevant document as well. It is not it is not possible to have to design an ideal system. So for some queries, it will be retrieving some non-relevant documents. For an ideal system, these two circles, or this circle and this ellipse will actually be overlapping. That is, all the relevant documents will be retrieved by the retrieval system. But ideally, this is not true. The retrieval system will be retrieving some non-relevant document, as well as it will not be retrieving some relevant document. So from that point, this confusion metric is coming into the picture. Now, considering this confusion matrix, we can define recall. Recall is basically the percentage of relevant document retrieved. Percentage of rel doc retrieved. So in the system, this is the total number of relevant document and how many of them are retrieved by the system. So if we write the corresponding mathematical formula in terms of this confusion matrix values, so what are the total number of relevant document? Total number of relevant document is basically this green plus brown. So brown is basically TP, the true positive, and the false negative. This is the, this is basically the total number of relevant documents, right? So it is basically it will be coming into the denominator, number of TP plus number of FN. So number of documents in the true positive set, number of documents in the false negative set. And in the numerator, I hope you can understand that it will be basically the number of relevant documents retrieved. Again, recall is the percentage of relevant document retrieved by the system M. So it has retrieved certain document, but out of the total number of relevant document present, so let's say this is the total set of relevant documents present, how many of them are retrieved by the system? If let's say there are 100 relevant documents there, and if the retrieval system is actually retrieving say 80 out of the 100 relevant documents, the recall will be basically 8 by 10 or 80 by 100 or basically 4 by 5. Similarly, precision is basically how precise the retrieval system is at retrieving the relevant documents. So how precise the system M is in retrieving the rel docs. Okay. So basically precision is, let's say M is retrieving this many documents. How many of them are actually relevant? That is, how precise are they? How precise? How precise the performance of the relevance of the retrieval model, such that it is retrieving only the relevant documents. So it will be basically, I hope you can understand, in the denominator it will be all the retrieved document. So in this diagram again, all the retrieved document is basically this brown plus this pink. So this, all the retrieved documents. So basically false positive plus true positive. That is all the positive documents. That is all the documents presumed to be or assumed to be or predicted to be relevant by the retrieval model. So this will be in the denominator, that is all the documents retrieved by the system, and then the numerator will be how many of them are actually relevant. So it is basically true positive, the brown portion here. So let's say the retrieval system is retrieving say 100 documents, and out of them 20 are only relevant. Then their precision will be basically 0.2. 0.2 will be the precision for a system like this. Now, one question that you might be having is, let's say I retrieve or a system say M or M prime is retrieving all the documents. Then in that case, what will be the recall? So M is retrieving all the documents, basically all the documents in the collection, M is retrieving. M prime is retrieving. Then what will be the recall of M prime for a given query? Anyone? Anyone at least try? It's a very easy question. Come on. I mean, this is the set of documents, and in this set of documents, the retrieval system is actually retrieving all the documents. Then what is the precision? What is the recall? First say what is the recall? Tell me. Anyone? So in the recall, what is the denominator? All the relevant documents, right? All the relevant documents. So let's say if the collection is containing 1000 documents, for a given query Q, relevant of Q, the number of relevant documents for Q is, let's say, 50. If a retrieval model M is retrieving all the 1000 documents, then what is the recall? Recall is basically the number of relevant documents in the set. Number of relevant documents in the set in the denominator and number of relevant document retrieved. How many relevant documents it is retrieving? It is retrieving all the documents. So that is, it is retrieving all the relevant documents as well. So the recall will be 1. That is, it is retrieving all the relevant documents. But note that this is not a very good situation, because in this case, precision, what will be the precision? So this will be the recall of M. Now, what will be the precision of M? The precision of M, I hope you can say. So it is actually retrieving 1000 documents, and in the numerator, it will be the number of relevant documents retrieved. So the precision will be basically, 0.005, isn't it? So out of, oh, I think I have given 1 0 extra here, it will be 0.05. All right. Ideally, an ideal system should only retrieve only these 50 documents. In that case, the precision, so basically precision of an ideal system will be 50 by 50, which is 1. The recall of the ideal system will also be 50 by 50. That is, all the relevant documents it is retrieving, it will be also 1. Okay. Great. So let's move on. Now, if we want to combine the precision and recall, there is a very nice methodology to do that. It's called, using harmonic mean, we can actually combine them together. So why we are using harmonic mean rather than simple averaging? Basically, we need to, if we can definitely use a simple averaging system here, which will be just precision plus recall by 2. But in that case, if one of them is pretty high and one of them is pretty low, it will be actually hampering the entire system or entire performance. Here, harmonic mean, using harmonic mean, we can actually kind of smooth that effect as well. So here, the harmonic mean will be basically, as there are 2 components, so 2 by 1 by P plus 1 by R, which will be basically 2PR by P plus R. Okay. So, and there is also, here, this is called F measure. And as we are considering the contribution of P and R equally, it is called F1 measure. In general, we can define an F measure as this. F equals to 1 by, there is a parameter here, alpha by, so earlier it is basically 2 by 1 by P plus 1 by R. Now, if we consider this 1, so that's why it is 1. Now, if I make it a parameter, like here it will be alpha, here it will be 1 minus alpha. So it will be basically, it can be considered as F alpha or something like that. Okay. Now, following that, we can also replace it. We can do some very trivial mathematics to come up with a formula like this, where beta is the controlling parameter which controls the contribution and P and R in the ultimate matrix value. Here, beta controls the relative importance of P and R in the ultimate matrix value, the value that we will be getting after performing the evaluation. If we set beta equals to 1, that means if we set beta equals to 1, we will be understanding that it is basically 2PR by P plus R. It is basically the F1 measure that we are considering precision and recall to be equally important. Now, if we consider beta equals to say 3, what we are doing is essentially we are considering in the numerator beta square plus 1 into PR. In the denominator, basically what we are doing is we are considering 9 into P plus R. So we are basically considering higher weight for the precision. Similarly, if we want to put higher weight for recall, we can set a value of beta to something to less than 1 value. Okay. All right. So in sum, precision measures the the ability of the retrieval system to retrieve the relevant documents at top ranks, and recall is the ability of the retrieval of only the relevant documents in the top rank. So if we retrieve more documents, that is, if we retrieve all the documents, I hope you have, I mean, with the example earlier that we have discussed, you've understood that if we retrieve more documents, higher is the chance of getting a higher recall, but together with that, the precision will be falling. Okay, so very basic trade-off between P and R is basically plotted here. Here in the x-axis it is recall, in the y-axis it is precision. So ideally a system performs like this. So in the top rank it will be retrieving some documents, and then later on it will be basically degrading. An ideal system should be having one precision, one recall. That is 50 out of the 50 relevant documents are only retrieved. But ideally will be, I mean, we can understand that will be basically between somewhere near here. If we get a precision of 1, that means returns relevant documents but misses many useful ones, because recall is almost 0. I mean, if we consider this straight line in the first place. Precision 1, but we are missing out. I mean, after retrieving some relevant document, the precision will be falling, or the precision will be definitely falling, because together with retrieving the relevant document, which will be increasing the recall, the precision will be decreasing. That is, it is expected that every time we are performing a retrieval, we will be retrieving some relevant document as well as some non-relevant documents. So so if we keep on retrieving, so let's say there are say 10 relevant document in the system, and a system is retrieving one relevant document and one non-relevant document in a pair. Every time it is basically, so rank 1 is relevant, rank 2 is non-relevant, then again rank 3 is relevant, rank 4 is non-relevant, and so on. So every time a relevant document is being retrieved, the recall is increasing. But as it is also retrieving a non-relevant document, the precision is decreasing. That's why higher the chance, if we retrieve more document, the recall will be increasing, the precision will be decreasing. Another similar way of measuring the performance is using accuracy. Accuracy is the fraction of documents classified correctly. So how many of this, so basically in this accuracy, how many of this, so this is the total number of documents in the present, in the corpus. It will be in the denominator, and in the numerator it will be just the number of retrieved documents, that is all the number of true positive as well as number of true negatives, which is basically, true negative is basically this. Okay, I think I have made a mistake here. It will be basically, I mean, true positive plus, let me just think of it a bit. Okay, sorry, it will be, sorry. Yes, exactly. So it is basically number of true negative. I have made a mistake here. It is basically the number of, I mean, true instances present in the system. So you can understand that this is the true instances present in the system. That is only the non-relevant document. So basically, if I consider the same diagram again, this is the collection and this is the set of relevant documents. So this is basically the set of relevant documents, and this is basically the set of non-relevant documents. So this is the true values, right? So it will be not the number of retrieved documents, but it will be basically the number of truly labeled documents. So it will be basically the number of true negative. So basically this portion, I mean the entire portion which is basically considered as retrieved, I mean considered as not retrieved, and also basically they are actually not relevant.